2 weeks in when they do proofs, our idea was have them draw that on a piece of paper, large piece of paper, have them label their, what comes next? F, G, I forgot the alphabet. Have them label their angles. From that they cut along those lines and measure up and work out which angles are the same. And that was...
My question for you, no, that's good. My question for you is, what's the question that drove the activity?
How to simplify a proof.
No. What did you ask them to actually do?
Nothing really, just find similarities.
Try to formalise the question.
I don't know.
Got any ideas?
Yeah.
So you've got them cutting it up, but they've got to cut it up for a reason.
Yeah.
The question is the reason because they're trying to do something.
They're trying to prove that there are angles that are equivalent when you have two parallel lines and the line going through it. That there are angles that exist that are equivalent.
But what's the question?
Prove that there are angles. Prove that there exist angles that are equivalent in this situation.
See, my other idea was, because in year 7 they've got to know the proof to prove a parallelogram.
Can we back up a bit? Come back to that one in a second. Keep that in mind. How about this for the question? Give them that on a big piece of butcher paper, and the question is, show. I wouldn't even use the word prove. I just say show that angle B equals angle H.
Okay. I would even start it before that and say, show that the two parallel lines are parallel.
I wouldn't.
No? Because they have to be parallel.
Okay.
Don't cognitively overload them.
No, I'm not.
We go
I think, see, they can't prove. How do they prove the two lines are parallel?
By just, drawing a perpendicular line from one to the other and seeing if they're right angles and if they're the same distance between one point and then another point.
The trouble is that sort of goes outside the bounds of this original problem for me.
Okay.
I'm not saying it's a bad problem. I actually think it's a really good problem.
Okay.
And actually one that would have a lot of... Can you keep that one in mind for a second?
Yeah.
All right?
Okay, so
if I said show angle B equals angle H, how would they do it? And this is the technique you're expecting them to use.
Yeah.
What would they do?
They would very elementary level, we were talking about cutting it apart and
Yep.
putting them superimposing them on top of each other, the angles, and then saying, well, these angles are all the same and these angles are all the same, and maybe making a list of those.
Okay.
And then
So if you say show angle B equals angle H, they can just cut out B, cut out H, put one on top of the other, they're done.
Yep.
All right? What I would do is something like give them the problem and leave it for them to sort out. Some people will just cut out B and cut out H and go, put one over the other and go, it's proved it.
Yep.
Other people may do different things.
They might measure the angles.
Measuring angles and these sorts of things. It depends on what comes up. But then what I would do, once they've done that, and we'd get to the stage of saying, okay, with their whatever techniques they've used, is everyone happy that angle B equals angle H? What they will have done initially probably is done a direct measurement of some way of comparing one to the other. Say, okay, I want you now to show me that angle B and angle H are the same. I'd give them a new piece of paper with the exact same diagram on it and say, I want you to show me that angle B equals angle H, but you are not allowed to compare B and H directly. How would you do that? And then give them another 5 minutes, 10 minutes to have a play. And then what do they have to do to prove it then?
Yeah. They'll have to say, well, B and A is 180 and G and H is 180. And
Yep. And then
G
and
is A.
and different groups will get different approaches. They will go, all right, well, B, vertically opposite, B's opposite is the same as D. They actually cut them out and measure them. So B equals D, D equals E, and E equals H is going through the equality relationships. Then you could also do because we know that B plus A is 180, so we can go B plus A is 180, A plus D is 180, A is common to both, so B equals D. And they can use other techniques. Then you've got the U rule. So you would expect a variety of different options coming out which would prove that B was equal to H.
They can do the B plus C equals 1,
They can.
and G equals an H and blah, 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 and on and on.
What's the purpose of all of these different ideas coming out? We're getting at the idea of a logical sequence of steps to establish something that we're trying to demonstrate. And how many ways are there to get to the thing we're trying to demonstrate? Multiple. That would be the activity. Yes. Yeah. Rather than just going up, because think about the way we've done it as compared to, all right, given that and go, show that angle B, that B equals H. And then immediately expecting them to go, well, B equals D, D equals E, E equals H, as on a piece of paper using these sorts of rules and all that sort of stuff. If anyone tried to do this, I would say, I don't want you to do that. I want you to actually show it for real on that piece of paper that it works. To get them all, because what you're trying to build is the idea of proof, the concept of proof in a qualitative sense, as a logical argument. No, okay, that's good. Happy with that? Go back. Now we go back to yours.
Actually, now that I think about what you just said about not writing in cognitive overload, I've probably been doing that all my life.
Yeah.
Yeah, but everyone does it.
Yeah.
It's something that comes naturally. You just chuck a heap of information at people and expect them to know it. They do it at university.
That's right.
Because you're writing constantly during the lecture and you miss half of what's going on.
Exactly right.
Yeah. You're writing things down.
People should either be thinking or writing, not trying to have to think and write at the same time. If you're doing anything new and introducing new concepts, they shouldn't be writing.
The problem with a lot of university lectures is they're not reinforced either. It's just, here's the material, you've got to know it for your exam.
Yeah.
We're not going to help you learn.
They see their job as to serve it up.
Yeah.
And your job is to get it down
But
somehow and work it out.
teachers were like that as well.
Yeah.
Here's your information.
Yeah,
This
fine.
is what you need to know. That's it.
Yep. Okay, so you notice how when we're introducing this, but this was another really good example that you've come up with, because what you're doing is you're building the idea of proof and what it means to do a proof, but you haven't gone anywhere near the formal mathematical language. When should formal mathematical language be used in a process? Right at the start, you've got to know the language before you do it, or once they've got an idea and understand things, roughly how things work, then you formalise the language, which is the better option. It's the second, take my word for it, it is the second one. Right? The trouble is, it's like if I try to speak French to you and then tell you what it means. When I speak it in the first instance, it's complete gibberish, it doesn't make any sense at all. But if you've got if I go, that thing there's a cat, and you know it's a cat, and then I go, okay, the French for that is this. What? You sure? That sounds very rude. Anyway, but the idea is that first connection, they have a thinking of an understanding of what it is and how it works first. You then formalise what it means in this new concept, in this new situation. And that's what we're doing here. All right? Now take yours. What the next one I would do, I'd love that to do that. After this, I would give them that one of yours. Put 2 lines, just any old 2 lines on a page. I'd have 4 lines, 2 that were parallel and 2 that weren't. And I go, okay, prove that which ones are parallel, which ones are not, and demonstrate to me, based on your diagram there, how you've come to that conclusion. And you're still not asking them to do formal mathematical proofs as such. What you're getting them used to is the idea of mounting a mathematical, logical argument. And then once you've done a few of those over a day or two, you then what I would do is then go back to the original problem that I'd done like this one and then show the mathematical way that we do it. Because cognitively, the load is they've already looked at it, they've already understood it, and they've seen it, and they know that these things, they know that they are the same. You then explain it in a mathematical way. So that reduces cognitive load. Does that make sense?
Yeah, they could have done this for us in school, but they didn't do that.
Okay.